Take a look around you. Your phone, your kitchen foil, soda cans, airplane parts. Aluminum is everywhere. It's lightweight, strong, corrosion-resistant, and incredibly useful. But here's the strange part. Aluminum doesn't exist in nature as shiny metal. In fact, it starts as something that looks more like dirt. So how do we go from reddish soil to one of the most widely used metals on Earth? The process is surprisingly intense, involving chemistry, electricity, and a lot of energy. Today we're going to break down exactly how aluminum is made, from raw earth to the metal you use every single day. Right here, on History of Simple Things. Believe it or not, aluminum used to be more valuable than gold. In the early 1800s, scientists knew aluminum existed, but extracting it was extremely difficult. The metal clung tightly to oxygen, forming compounds that were hard to break apart. In 1825, Danish scientist Hans Christian Ørsted produced small amounts of aluminum, but it wasn't practical for large-scale use. For decades, aluminum remained rare and expensive, so expensive that it was used for luxury items. Even the tip of the Washington Monument was made of aluminum because it was considered a precious material at the time. Everything changed in 1886 when two scientists, Charles Martin Hall in the United States and Hall-Héroult in France, independently discovered a new method to extract aluminum using electricity. This breakthrough, known as the Hall-Héroult process, made aluminum production much cheaper and scalable. Practically overnight, aluminum went from a rare metal to an industrial powerhouse. Aluminum starts its journey as a rock called bauxite. This reddish-brown ore is found near the Earth's surface in tropical and subtropical regions. Countries like Australia, Guinea, and Brazil are major producers. Bauxite isn't pure aluminum. It's a mixture of minerals, primarily aluminum oxide, along with iron oxides and other impurities. To get aluminum out of it, we first need to separate the useful part from everything else. Mining bauxite is relatively straightforward. Large machines scrape off the topsoil and dig out the ore, which is then transported to processing plants. But at this stage, it still looks nothing like metal. Once the bauxite reaches a refinery, it goes through the Bayer process, named after Austrian chemist Carl Bayer. This step transforms raw ore into a white powder called alumina, or aluminum oxide. Here's how it works. The bauxite is crushed and mixed with a hot solution of sodium hydroxide. This dissolves the aluminum-containing minerals, leaving behind impurities like iron and silica. These impurities are filtered out as a waste product known as red mud. Next, the aluminum-rich solution is cooled, and tiny crystals of alumina begin to form. These crystals are then heated to remove moisture, leaving behind pure alumina powder. At this point, we've removed most of the impurities, but we still don't have aluminum metal. The aluminum is still chemically bonded to oxygen, and breaking that bond is the hardest part. This is where things get intense. To turn alumina into aluminum metal, we use the Hall-Héroult process, which relies on electrolysis, a method that uses electricity to drive chemical reactions. First, the alumina is dissolved in a molten substance called cryolite. This lowers the melting point, making the process more energy efficient. The mixture is then placed in a large carbon-lined container called an electrolytic cell. A powerful electric current is passed through the molten mixture. This current breaks the bond between aluminum and oxygen atoms. The oxygen combines with carbon to form carbon dioxide, while pure molten aluminum sinks to the bottom of the cell. This liquid aluminum is then siphoned off and cooled into solid form. But here's the catch. This process uses an enormous amount of electricity. Producing aluminum is one of the most energy-intensive industrial processes in the world. That's why aluminum plants are often located near cheap and abundant energy sources like hydroelectric dams. Once the aluminum is extracted, it's poured into molds to form ingots, slabs, or billets. These are then processed further depending on their final use. Aluminum can be rolled into thin sheets, extruded into complex shapes, or cast into specific forms. This versatility is one of the reasons it's used in everything from beverage cans to aircraft frames. It can also be alloyed, mixed with other elements like magnesium or silicon, to improve its strength and durability. Pure aluminum is relatively soft, but alloys can make it strong enough for construction and transportation. Here's something remarkable. Aluminum can be recycled almost endlessly without losing its quality, and recycling it uses about 95% less energy than producing new aluminum from bauxite. That means your soda could be melted down and back on store shelves in as little as 60 days. Because of this, aluminum is one of the most recycled materials in the world. This not only saves energy but also reduces the environmental impact of mining and refining. So the next time you hold an aluminum can or tear off a piece of foil, remember what it took to make it. What started as a chunk of reddish rock went through crushing, chemical refining, and an energy-heavy electrical process to become the lightweight metal we rely on every day. It's easy to overlook something so common, but aluminum is a perfect example of how science and engineering can transform raw earth into something incredibly useful. And perhaps the most impressive part? We've gone from treating aluminum like treasure to using it to wrap our leftovers. That's progress you can literally hold in your hands. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.